what are some of the most important architectural practices that you rely on when you're designing cloud environments that can handle, like you said, unpredictable demand and still remain reliable?
Our typical kind of principles are very sort of container focused, but regarding sort of the principles that we look at, it depends on the traffic flow normally, or the traffic patterns. So is it going to be an application that's going to serve sort of quite continuous amount of requests and traffic, almost sort of a 24/7, or is it something that's very, very spiky, almost like you turn it on and it's very short-lived, and then as we come out of race day, it will then die back down, and then we might sort of lean to different architecture principles.
Cloud and DevOps engineering has transformed dramatically in just a decade, yet many teams still struggle to keep pace with the breakneck evolution of tools, practices, and expectations. From the shift to containerized workloads to the rise of AI-driven automation, the ground keeps moving, and the best strategies today may look completely different tomorrow. Today's guest knows that journey firsthand. Ryan Kirk, head of Cloud and DevOps at Formula One, has built and led high-performing teams through this rapid change. We'll speak about how the cloud and DevOps landscape has evolved, the core architectural principles that keep systems resilient under unpredictable demand, and where AI and automation are creating the next wave of opportunity. If you're an engineering leader, architect, or tech strategist looking to future-proof your infrastructure and stay ahead of the next big shift, this conversation will give you both insight and actionable ideas you can start applying right away. Before we jump in, I want to tell you about our AEC PM Connect event, built for project managers who want to improve project delivery, communication, and leadership through practical sessions and tools. These events provide an avenue to connect with leading PMs in the industry. Our next event will be on June 10th, 2026 at the Forest Gate Country Club in New Jersey. Visit aecpmconnect.com and register today. I hope to see you there. It's now time for our conversation of the week with Ryan Kirk. Ryan, thank you so much for taking the time to join, and welcome to the show.
Thanks, Nick. Good to be here.
Excellent. So I think Ryan is a guest that has a little bit of a different background than we're used to having on the show, which I think is awesome because it brings a different perspective. So Ryan, I'll let you tell a little bit more about yourself to the listeners. Please go right ahead.
Sure thing. So I'm Ryan Kirk. I'm head of Cloud and DevOps at Formula One. I've been around the company for coming up to 15 years now, from sort of the age of 16 on, and doing kind of desktop support and summer internships. Graduating university, joining when I was 21, and have been in the company full-time for 10 years, going from desktop support, moving into trackside systems engineering, so responsible for all the infrastructure that was putting on the broadcast. So quite sort of bespoke systems, video systems, data acquisition and processing, before then moving into the cloud space and putting kind of a lot of attention on that through our partners such as AWS, and then looking into the DevOps space and sort of fostered and built out a greenfield DevOps function within Formula One. And nowadays look after the DevOps team, the cloud engineering team. We do AI, MLOps, on-prem Kubernetes from Track to our UK platforms, and also, of course, in the cloud as well. So mixed bag of different things that we look after, but certainly keeps us busy.
Which is, and like we were discussing before we hit record here, right, Ryan? Like what you guys do is really interesting to me, and I'm sure to the audience, because when you think of F1, right, you're thinking about race day and what gets shown on TV, but there's a lot of work that goes on behind the scenes to make that all happen.
Yes, there is, and it goes without saying. There's always a bit of setup, right? But it's not often seen on kind of just how much setup goes on in the background on the lead up to that race day. Starting from our physical rig, so our team of riggers will go out weeks before and start sort of offloading the physical kit and making sure that everything's in place for when the technical teams turn up. So it's typically on a Tuesday of race week. So you're talking sort of, what's that make, sort of five days out, something like that. And then, so that's all in place for our broadcast engineers, network engineers, IT operations engineers, most of the technical teams. And then we power everything up. And essentially what we're powering up at the track is think of it sort of as a mobile data center, which is all built in-house, including the containers that they sit. And they get sent these containers individually and then sort of hooked up, powered on, making sure that there's no technical issues, because these things happen, especially when you put in technical equipment on the back of planes and lorries and forklifts and all kinds of stuff. And then we ensure that all of our systems, local area networks, wide area networks, applications, compute platforms all power up and are healthy. And then we go through a full systems test on Thursday. And then once that's over, we go into a full change freeze type operation from then until race day. So by the time Sunday hits, everything's been thoroughly tested, all issues ironed out. Yeah, and then we're good for the race.
Which is amazing, right? Because you guys are essentially bringing a data center on the road to the location of the race, right?
Yeah, pretty much. And when we have less of a footprint at the track than we used to. So we did used to send everything to the track in terms of all kinds of processing. The director used to be there in terms of the person who actually directed the show. All the camera editors and camera racking and everything used to be at the track. And then we moved into a remote operation. And a lot of that's done back in the UK, but we still have that trackside presence for all of our data acquisition. So telemetry, acquisition, video, team radio, stuff like that. So we do still send sort of a mobile data center. So it's it's an interesting model. We know if something's been rattled around a bit, we have to sort of reseat certain components and stuff within the kit, and that's just on the sort of physical side. Naturally, we've got the cloud side as well, which is naturally less physical, which is quite nice. But we can go in there and we have to scale up all of our services and making sure that they're ready to receive the race data and the traffic and serving the broadcast.
And that's exactly what I was going to ask you about, X Ryan. So great segue there. So we've talked about the physical infrastructure that is put in place to make it all happen. But what are some of the most important architectural practices that you rely on when you're designing cloud environments that can handle, like you said, unpredictable demand and still remain reliable?
Well, we're a container house. We're a Kubernetes house. So our typical kind of principles are very sort of container focused. But it's all about regarding sort of the principles that we look at, it depends on the traffic flow normally, or the traffic patterns. So is it going to be an application that's going to serve sort of quite continuous amount of requests and traffic, almost sort of a 24/7, or is it something that's very, very spiky, almost like you turn it on and it's very short-lived, and then as we come out of race day, it will then die back down, and then we might sort of lean to different architecture principles from that perspective. So something might be, I don't know, serverless or event driven or something like that. So yeah, it all depends on the usage, I guess, from those apps, and then we lean into the certain patterns and principles sort of feeding off of that.
It's cool, right? Because whether you're in my field, which is more civil structural engineering, which relates to more of the physical infrastructure, or your field, which deals with both, but as we just discussed, is dealing in this portion of it, at least more with the cloud, you have, certain principles and ways that you go about the engineering, just depending on each scenario, which I'm sure each one has its own unique characteristics.
Yeah, 100%. And I think the way sort of approach the two sort of areas aren't too dissimilar. I don't think you are looking at sort of the structure of these systems and the design and trying to anticipate what they look like before they sort of undergo the stress testing and all that sort of stuff prior to sign off. So yeah, it's definitely sort of they're akin in a way.
Absolutely.
Transform your technical experts into impactful leaders with EMI's Engineering Leadership Accelerator. Tailored for AEC professionals, this program enhances communication, delegation, and decision-making skills. Flexible, interactive, and designed to fit your team's schedule. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on corporate training.
And then, Ryan, could you just for the audience give just a brief overview of basically what cloud and DevOps are in the context of what you do, and then how the landscape of cloud and DevOps has changed since you began your career, and then what shifts have most influenced your kind of system design and the way everything runs today?
Yeah, sure. So at the moment, I guess for what it sort of means to us is we use the cloud for a mixture of things. We use it for a mixture of 24/7 services, sort of very much kind of multi-region, high traffic web applications and stuff like that. We've got a series of bespoke workflows and applications which serve the race. So stuff like you may have seen AWS Insights if you watch the race. So they're all served from the cloud and are all sort of hosted and run there. We have sites that serve our editors, so we've got sort of video archives and things like that. So it's very mixed within Formula One. There are a huge variety of different use cases, applications, areas of the business that consume those as well. So it's to kind of summarize it, it's like a sort of big tool chest, I guess, of different systems, different workflows, and different requirements as well. So that's it sort of from the cloud side. Obviously, we're sort of multi-region and all that sort of stuff. And then from a DevOps perspective, so DevOps is not, I wouldn't say it's new. I wouldn't say we've had the function officially as long as, you know, some other companies or enterprises. But so it's looking at it's been a greenfield process, which has been quite nice. And that's started to take shape from sort of a race side in terms of kind of different race-based automation, which is a fairly sort of unique thing, I guess, to F1. We have, again, it comes back to that quite unique model. The problem is when you've got a data center that travels from race to race, once it gets packed up, you don't have any access to it until it gets powered on the next race, and that can be, if we take in our summer break, that could be in a month's time. So we rely quite heavily on automation to save operators time, to keep things consistent, to keep things all within change control and governed. And then you've got the DevSecOps space that kind of feeds into all of that. So it keeps our operation safe from a security standpoint, but also operationally as well, and being able to sort of free up the engineers at the track, as well as Biggin Hill as well. And then not to mention sort of your traditional DevOps, CI/CD, and all of those sort of areas. But we do have the sort of custom, I say slightly custom, but the slightly newer terms, the ops terms, as I call them, where we GitOps and MLOps and AI ops as well. So all of those sorts of things, which we're looking at from a DevOps perspective, which we have patterns and processes for, and some are slightly newer. So the AI ops, for example, it's as I think quite a lot of organizations, they're quite developing them quickly, but you know, we're not quite there yet.
And at least, Ryan, what it sounds like to me is even as things change and, you know, you have new tools and technologies at your fingertips, it's all still based on engineering principles, right? Which for you guys, right, we talked about you had your own set of principles and the way you go about essentially running your shop. And then for those listening, right, a lot of civil, structural, mechanical, other more physical engineering, right? It's the same idea, just a different, let's just say, niche or type of engineering. But I think that makes it easier to relate to, right? Because, you know, I think you actually had a really brilliant analogy is, you know, you guys have a system, right? You're building it to withstand the stresses of, right, essentially people coming to watch races. We have, right, systems, if you design the data center to resist stresses from gravity, wind, earthquakes, right? And all those different features that go into designing a building. So that's at least how I like to think about it, right? Because you can never be an expert in everything, but it definitely makes it easier to relate to what others are doing in other engineering disciplines.
Yeah, I agree. I think the fundamentals are key, and it's such an obvious sounding thing, but I think where so many new things are coming out, you know, take AI as a good example, then still relying on your core principles and the things that kind of really sit underneath, and having that understanding, it is so paramount to then, you know, everything else, I think. And so 100% know that it's something that should never be lost. And then as things come on board, then, you know, they all feed into those. So
excellent. And now let's, you know, shift the topic to culture and people, right? Which no matter what engineering discipline you're in, we're always going to be dealing with people, working with people to make things happen. So what strategies have you found effective for fostering a DevOps culture, especially when you have to lead multidisciplinary teams or introduce new engineering practices or tools or technologies?
So having kind of the experience of building a DevOps team greenfield, what I found to foster the DevOps culture is I call it the Fields of Dreams approach, which is like a build it and they will come. And I think that's quite important for DevOps culture, and it's something that we've seen great success in. And if there's an idea, and even even if the sort of the other parties are sort of a bit hesitant, or they feel that actually that particular idea might not bring in the value that they're after, allowing, just kind of building these things and showcasing the power of what DevOps can bring to an organization and how truly transformational it can be, I think is key to fostering that culture. Because when you show what it can do, it might be addressing a problem, it might be more of a challenge-based approach. So inviting people to challenge DevOps, saying, can you make my life easier with this process or this process? And it can be as wild and crazy as it can be. But then as you start to maybe sort of address some of those, or even if you're getting sort of 50% of the way or 60% of the way, you still made that process 60% more bearable or 60% quicker or whatever it is. And I think that then gets the ball rolling, and then more ideas come out. That, from what I've seen, more ideas start coming out of that. I'm going, well, that's actually fantastic. Actually, what's other process? Could you have a look at that? And then before you know it, you've got all kinds of momentum. So that's, and you obviously got the innovative side as well, that challenge-based mindset. Okay, these processes are great. How can we make them better? How can we improve these workflows, even if it's, I don't know, from a reporting side or from a speed side or governance or whatever. And I think encouraging that is basically sort of not be disheartened, and just go, and if you think that you've got an idea is great, that you think is good, go and do it, showcase it, and I think you'll find that the feedback is fairly positive most of the time.
And I like how you laid that out, right? And at least the phrase I like to use is people, process, and technology, right? And we've talked about the people portion of it, you building the teams, the process portion of how you guys actually lay out what you're going to do and make things more efficiently. So then my next question is more on the technology side. So where do you see the most meaningful opportunities for AI, automations, or any other technologies to enhance what you guys do on the cloud and DevOps side? And then how do you actually evaluate the tools, methods, et cetera, that are worth adopting?
It's a good question. So I think that I think AI and automation is great for gap filling, I think, and that's subjective to the organization. But sort of take an example, we had a fairly successful product go live fairly recently where we're a bit more of a unique organization in terms of our operating model. Root cause analysis on technical issues is quite difficult. There's a lot of places to look. There's a lot of cross-team communication, as you can imagine. And we built, and that was almost our problem statement, should we say, or the thing we wanted to address. So we used AI to build a root cause analysis tool that was hooked into all of our different applications, hundreds of applications, and it allowed parallel investigations to happen based off of a user prompt. So the user could say, I'm having this, here's what's reported, here's the timestamp, and it would go and collate all that information, correlate the information, and come back with a root cause. So I would say sort of definitely sort of around that. I mean, in cloud and DevOps automation, if you're freeing up, even if it's, there's a great matrix actually out there where it's something like, if you spend 3 minutes doing a task each day over the course of a year, you have this kind of massive compounding effect of actually how much time you're doing it. Whereas if you automate that, although even if it takes you a couple of days to automate, you might think, what's the worth if I'm doing this for the sake of a 3-minute task? You do that going through sort of many tasks, it creates a huge effect. So I think automation in that space for sort of DevOps-based automation is produce huge impact if you continue down that road. And I think with AI specifically to cloud, I think having the integrations within all the different platforms, different applications and services, which the cloud providers are making a big effort to do, I think that's, there's going to be sort of a lot of benefit in that space. But when it comes to picking tools, we're quite an in-house. We like to build our own, I must admit. So we typically, if we see a cool tool, we would typically go, should we try and build it ourselves, or should we try and make it a bit more unique to really hit home on our use case? But I think if we were, I mean, we do pick tools, we don't 100% develop in-house from that perspective. But if we were sort of going to pick an AI tool, it would be quite a common one is, does it work on premise for us? Because we
Mm-hmm.
that. That's an interesting conversation because a lot of them are sort of SaaS-based products, which if you've got SaaS-based workflows, is absolutely perfect. But yeah, just making sure that it fits all of your use cases, making sure that you have flexibility in the tool is certainly something I'm a big fan of having the ability to choose specific model. Model choice can be a subjective process. So some people prefer different models. So I think having something that we look for is definitely flexibility on what the AI is. Can we leverage different models? Are we empowered to do that, or are we restricted to what the tool has been written for? So that's something that we do also look into because we love the flexibility aspect.
Excellent. And when I think on-prem, right, the first thing I think of is security, because
Yes.
you start to look at some of these commercially available models, right? You pay, $20 a month, maybe using the free version, right? But what that provider does with your data, maybe not the clearest thing. But by going on-prem, and correct me if I'm wrong in any of this, right? If you're essentially hosting models, whether they be open source or if you've created one yourself, right, you start to have more control over the data that you would put into these AI systems, whether they're large language models or something else, which I think for you guys, right, would give you that flexibility to know more about what's happening with your data.
Yeah, 100%. I definitely should have led with security. My InfoSec team, they're going to pull me up on that one. 100% security, or that's the first thing we look at. But no, 100%. Yeah, exactly. That is that. Looking at what those back-end providers are. So where is the data ultimately being sent to in the back end? Is it, what platform is it? OpenAI's platform? Is it Google Vertex? Is it what is that? And then it shapes that picture of, okay, well, it's been sent to this provider, and as you said, seeing how that data is processed. Is it a shared tenancy? Is it single tenancy? Do you get kind of your own in the back end? Is it your own environment spun up for you? So then you have your own place that your data's going, or is it the same entry point for all the different customers? And as you said, when you bring it on premise, where it's literally under your roof physically, that certainly helps those conversations because we can wrap anything that we want to around that, whether that be network segmentation, any security really, hardware isolation, whatever. But at least we know what that looks like, where it's going, and we can track that.
Excellent. And then, bleeds into my next question here, Ryan. So then how do you strike the right balance between rapidly innovating, right, which comes with disruption, trying different things, and of course failing? That's just part of the game. But the equally critical demands of reliability, performance, and security, right? Because you guys had an operation to run. And, if you've ever watched an F1 race, right? Things tight, things are moving, right? And you guys need to be on your game. So then how do you balance essentially this critical production with being an innovative team?
Yeah, so this question is quite sort of close to heart, really, because we walk the tightrope, and we walk it very well, but we are rapidly innovating all the time, and there is always something that is going on, that next event, in terms of whether it be sort of an application modernization, whether it be a new product entirely, whether it be a new architecture, physical architecture, network design, whatever it is, to them, or to proof of concepting, ML based object camera recognition, or whatever it is. But we have to do it in a way that's safe. We have to do it in a way that's secure, because we would not want to put our broadcast operation, or any part of our operation, in fact, at risk. So here's a challenge, and as I mentioned earlier, especially sort of on the track side, that gets shut down on a Sunday evening after the race, and then we don't see it until the next event. Luckily, with our cloud space, we have 24/7, which is great. But yeah, to kind of keep that momentum, that innovation moving, we have a very curious set of engineers, which is, I think, is definitely a good thing. Going out there, seeing with new technology comes out, there is always that kind of mindset of exploring of what can it do. And I think that's the first step of, we encourage that very actively in terms of, go out there. If there's something that you think, even just an idea, bring it to the table, see what we can do, and whatever area that is. Having the environment set up to be able to freely and safely develop and test these things, I think is incredibly important. So that's definitely something that we do have. So we have that on-prem, we have that in the cloud, and we have development environments for most of what we run. And we also have our own simulation-based systems, so we can simulate a race if we want to, which also helps. But it's also encouraging people just to, if it doesn't work, it's fine. And I think that's it. So from the innovation side of things, is that you then remove all the hesitance of even if an idea is quite blue sky, just going and doing that. And if it fails, okay, well, it fails on to the next one. And I think getting used to that, almost a bit of a numbing effect to, I don't want to call it failure, because that's got sort of negative connotations, but to something maybe not being as suitable as you intended, or might be complex or whatever. I think that it then becomes another part. You just go, okay, well, on to the next idea. Then, of course, we get into the ensuring reliability and security, and that is just thorough testing and making sure that when we get to that sort of production state, we do have an idea of how much it scales. We do have an idea of how it handles load. Chaos engineering principles always help. What happens in failures? What's the downstream effect of that? What's the recovery time? And all of that, having the understanding through rigorous testing and automated testing as well. I mean, that again, coming back to that DevOps methodology and ethos of taking that human element away. If you can automate all of this, or at least part of it, then your engineers can focus elsewhere, and they can focus again on innovation, and it's sort of a bit full circle. And then naturally just keeping security at your forefront through the development process, because if you leave it until the end, and then your cyber security teams, your information security teams then pull you up on it, well, that could actually set you back quite some time if you then have to go and re-architect your application, or you have to rewrite it, and also it can be disheartening. So I think doing that from the off and integrating that within development processes, starting from writing the code to then through all of your CI and your deployment processes, and picking that up on the way through and flagging it as early as possible so that it doesn't interrupt. And I think that those sorts of areas, if you've got those quite nailed down, I think it allows people to sort of fail fast, move on to the next thing, but also as stuff's going through, it's coming out the other side secure. It's been tested. It's the reliability factor has been documented. We understand the behavior, so that when it does go into production, we're ready, because we can only test a race on race day, which is that's ends its challenges. So we know when it works, 100% when it works, when it's race day. So we need to do all of this very, very thorough testing to make sure that when we get to that point, we have the confidence that when those cars when they're lined up at the grid and they're about to go off, then we're all good. So that's how we try and do it anyway.
Beautifully said, right? And what I heard, and how I think the audience can apply that, even if they're not in your guys' specific domain, is just the process of innovation, right? Like whether you call it failing or a different word, it's just part of the process, right? Trying, even if it doesn't work out as you intended, keeping security at the forefront, right? And doing your security reviews up front, so there's less wasted time and effort in getting that team involved. And then testing, whatever that means to you in your specific niche. I know, right, for us, like in the building industry, right, you get to build a building once, and you try to do as much testing or commissioning or other sorts of terms to simulate the building's performance before it actually gets built. So I really enjoyed the way you put that together, because I can definitely relate, as I'm sure the audience can, from their individual niches and practices.
Yeah, no, it's a very good point. Again, fairly akin. We have that one chance to get it right, and we know if it is right once we're there, really. So yeah.
So I guess maybe the advantage we had is, right, that building stands for hopefully a couple decades at minimum. your guys' races are over a little bit faster. So we've got a little bit of time to correct some stuff on the back end if needed. Brian, can you share a technical challenge from your own work that required creative problem solving? And then what did you learn from that experience?
Sure. So we recently built an application or a system called Team CDS with our partner Globant. And what it is a real-time content delivery system for the F1 teams. Now, this is through video, so it allows the Formula One teams, as the race is going on or qualifying or whatever, to look at different videos, onboard cameras, and all of that sort of stuff. Now, the problem being is that, the challenge was that the teams have a split operating model for this application, or they had a split requirement. And that is the team's factories, which are dotted all over the world, so their sort of mission control rooms style setup that they have, will be consuming this system from all over the world. We then also have the teams at the track, so the pit wall. So the teams that are actually on the pit wall are using this application. Now, for them, they need it real time as humanly possible, because imagine a car's going 220, 230 miles an hour, if they've got a second delay in terms of distance, that's quite far. If they're seeing an event for each second behind what it is in real time. So, and it's a cloud-based system. So how we had to come up with quite a creative way of how do we host something on the clouds that is ultra real time to the F1 track and is consistent as well. And so we essentially built an on-premise CDN for delivery specific to the track, although it's all hosted in the cloud itself in terms of the application. But we had to build reverse build a CDN back on premise to allow the teams at the track to consume it sort of ultra real time. And we got sort of it was single digit seconds from the car going around the track in 220 miles an hour to our pickup system, RF pickup, and all the encoding, decoding chain and all that sort of stuff. So that was one where we had to get a little bit creative, because this is great, but we need it quicker, and quite considerably quicker as well. So that was an interesting challenge, but it was good fun to kind of get behind the whiteboard and see what we can do there.
Which is pretty, like, the requirements behind something like that are pretty amazing, right? Because as you said, 220 miles an hour, and then even very short amounts of time in delay translate to relatively large distances at that speed. So I think everyone can kind of relate to that, right? Like, you look, your head's here, and then you turn it, and the thing's gone, right? So you guys being able to come up with a creative solution to get your stakeholders what they needed, essentially, I mean, that's pretty incredible.
Yeah, no, it was a good one, I must admit. But hey, we got it there. Everyone's happy, which is the main thing.
Beautiful. And Ryan, what emerging technologies or trends in cloud engineering excite you the most? And then how do you prepare yourself and your teams to adopt them?
So it wouldn't be a tech conversation without AI. Don't get me wrong. That is, I'm sure that everyone is excited about where that's going and where that's heading. But one that I'm personally excited about, and is very much in its infancy, very much kind of looking ahead, is the world of quantum computing and where that's going to end up. I don't know, this is kind of where I feel it's like where AI was sort of 10 years ago. Of this, these companies are coming out and the services available. I mean, through our partner AWS, they have Amazon, they have Bracket. So there's exposure to quantum technologies and quantum computing, which I'm personally quite excited about, and seeing where that's going to end up and what uses will we have for that. No idea at the moment, but hopefully in the not too distant future we'll start building those use cases. But quantum computing, AI as well. I think they're great technologies, and also some of the sort of emerging based stuff like satellite based connectivity as well. That's looking looking pretty good. There's the improvements in that space over the last sort of even 3 or 4 years, and the amount of services that are sort of being put forward out in that space as well is quite exciting for me too.
Excellent. And then Ryan, for the audience, could you just give a layman's breakdown of what quantum computing is, and then how it compares to like the trends you're seeing with artificial intelligence?
Sure. So quantum computing, essentially, if you think of a classical computer, your binary, your 0 and 1s, the fundamentals of what a computer does and is from a machine perspective, I guess. A quantum computer, so a bit, a 0, it can be a 0 or a 1. In quantum worlds, it's ends up something called entanglement, and that is where a bit can be a 0 or a 1 at the same time. And without going really into the nitty-gritty, it's through quantum computers are ultimately a completely different architecture using quantum mechanics, and the sort of seen outcome, I guess, or the predicted outcome is once they start sort of productionizing these fully, is that we have this kind of infinite amount of compute power and efficiency. So it will solve huge problems and from a computation perspective anyway, everything from pharmaceutical development to processing of large data sets and AI and all this sort of stuff. So yeah, it's from kind of a real high level summary, I would say that's probably it. But and where it kind of goes, where I see it going with AI, I think that with AI at the moment, there is a huge amount of compute resource required and power to run these models and to train these models. I mean, I think it accounts for something like 2% of the global energy output, which is huge. And I think that eventually there will be a point where the models will become so big and so complex that it's going to be difficult to scale from a power perspective, from a physical, everything from the amount of chips required to the amount of space and the amount of cooling, the amount of power that runs these things. And I think that when quantum computing eventually comes on board in a bit more of a regular sense, and it's a bit more of a regular technology, I think it will start to be able to power these and train these models, but way more efficiently, way less infrastructure, and overall just a lot more efficiently, not requiring so much huge amounts of GPUs and power that goes into them. So that's what I think anyway. We'll see.
Which then, from the physical infrastructure perspective, and correct me if I'm wrong in any of this, but if you don't need as many square feet of data center to host all these GPUs, server racks, etc., right? Water for the cooling systems and so on and so forth, because it sounds like quantum computing is more efficient than what we currently have. That's less strain on the environment, right? Less space needed, and maybe better use of what we have from our existing infrastructure.
Yeah, exactly that.
Beautiful. Ryan, thank you again so much for taking the time to join us. One final piece of advice that you'd like to share with AEC leaders, engineers, or tech strategies about integrating AI and modern cloud practices into their projects. Have you had anything for us?
I would say start with the problem. So look at a problem that might be caused either internally or an issue that either internally within your own company that you're facing, or you feel that customers are up against. Focus on that, and then look to AI. How can the AI solve that problem? And then it helps the process. And that would be my advice. Focus on the problem.
Excellent. And I'd call it, right, a problem in search of solution instead of the other way around, because it becomes easy to get distracted by cool looking technology, and getting back to business fundamentals and solving problems is really where we need to be, no matter what industry you're in.
That's it. Yeah. Focus on the problem and then focus on the tech. That's the fun bit.
Really well said, Ryan. So again, thank you for taking the time to join us today. If the audience has more questions for you, would like to connect with you afterward to discuss anything we've chatted about here today, what's the best way for them to reach you?
I would say LinkedIn. drop me a connection request on LinkedIn and say that you've seen the podcast, and and then we'll chat.
Excellent. Ryan, thank you so much again for taking the time to join us today. It's been an absolute pleasure. And until next time.
You're welcome. Thank you for having me.
Absolutely. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all your engineering and technology endeavors.